Algebra 2, Unit 1, Test. We had a test this week in Algebra 2 Honors, and this video serves as a review of that test. So the test really not that hard, but very comprehensive, and it really covered everything we did so far. Problem 1, what is the range of the relation shown in the table? And this has to do with, in part, understanding the distinction between domain and range, which we're going to use through this test, throughout this test. Well, range would be the y values if you look at xy coordinate plane. So we're looking at these values here. And so we have these set notations for all these values, and our correct answer can be none other than C. Okay. Next, 2. Which are the correct representations of the intervals shown on the number line? The key thing is understanding what these points are. Is this an open point or a closed point? No. Okay, if it's open point, A would be a correct answer. Now, the second one, B, x such that x is greater than or equal to -2, is that correct? And less than or equal to 4, is that correct? Yes. And also, next, in interval notation, bracket between -2 and 4, is that correct? Yes, the bracket is equivalent to the point on each end of the interval. So C is a correct answer. And D, okay, now if you look at C and D, they have to be opposite. So let's go in, we cross these out, let's fill in the circles here. No, yes, yes, no. Okay, next we'll go on to problem 3. Olan earns $25 per week for his allowance plus $15 for each lawn he mows. He wants to earn at least $100 each week. And I made a change of this thing, right? And inequality I put on the test. To represent the situation. And what you have $15 for each lawn, but $25 per week, and we want to know to earn $100 each week. And so your fixed number is this 25 for any given week, plus 15x is going to be greater than or equal to 100. And so that would be this inequality or an equivalent to it. Some people, a couple people put an equation instead of inequality. And then how many lawns must Olan mow to meet his weekly goal? And what we say is must Olan mow, and that'd be the minimum. And so right here, if we put 25 plus 15x is greater than or equal to 100. And I saw a lot of people, when I was grading it, just work out an inequality like this. We get 15x is greater than or equal to 75. If you divide by 15, you get x is greater than or equal to 5. So 5 lawns mowed. So that's that one. Next. 4. Find the inverse of f of x equals 2x plus 1. Well, I've talked about the 4-step process to finding an inverse of a function. First step, change that f of x to y. Second step, switch x and y. Third step, solve for y. Subtract 1, subtract 1. So we get 2y equals x minus 1, and then we divide by 2. Y equals, now we have x over 2 minus 1/2. Now if you left it like this, y equals x minus 1 over 2, that really is a correct answer. And the last step I'm going to do is take, well, I'm going to do one more step. I'm going to change that x over 2 to 1/2 x minus 1/2. Not that you had to do that to get that correct. And then finally, in inverse function notation, f negative 1 of x equals 1/2 x minus 1/2. And then you put that up here. Now, if you got these numbers right, basically, and put them in a slightly different form that was correct, you still got full credit for that. I think even if you put y equals that, I give you credit in that that was an inverse. It doesn't say function notation. So anyway, this would be your best answer for that one. Refer to the figure below for 5 and 6. Write the domain and range of the function interval notation. Here we have a linear function, and the domain of a linear function is going to be all real numbers, which is greater than negative infinity, less than infinity. And your range is going to be the same, all real numbers. Now, these are the basic things I'm looking for. Interval notation is key. If you didn't, if you put some other notation besides interval notation, you probably got a little something taken off. 6, describe the end behavior of the function. Well, as x approaches infinity, what you got to look for end behavior is range. So as x approaches positive infinity, y approaches infinity. That's your range. And as x approaches negative infinity, y approaches negative infinity. That's the other end of the range. So your correct answer for this is B. Next, 7, determine whether the following functions are inverses of each other. And again, just like we did on that earlier problem 5, you can take the inverse of this function, see if we get the other one. And there are ways of looking at it too. I forgot to do that for the other one. We'll look at this. We have, I'll do it for this one here. We have, I'll put y is equal to 1/2 x minus 11, and then we're going to switch x and y, so we get x equals 1/2 y minus 11. Next step, solve for y. So if we add 11, I'm just going to work down from both sides here. So we get 1/2 y equals x plus 11. Now if we multiply both sides of this equation by 2, we get y is equal to 2x plus 22, which is what we have here for, that is that one right there. Are they inverses? Yes. Okay, next, B. We have, I'm going to work it just down this column here. We'll say, we'll take this g of x1 and see if it, we take the inverse fx. So we have y equals 1/3 x, switch x and y, x equals 1/3 y, multiply by 3, we get 3x is equal to y, which is what this is over here. And so that is a correct inverse function. Next up, C. Okay, that's going to be B here, A here. I'm going to work C over here. We have, change that to y equals x minus 6 over 10. And then switch x and y. X equals y minus 6 over 10. multiply both sides by 10, we get y minus 6 equals 10x. And then if we add 6, we get y equals 10x plus 6. Is that what we have here? No, we have 10x minus 6. So no to that one. And the last one, D, work below here, we're going to change this to f of x, well, we'll change to y equals 7x minus 3. Take the inverse of this, x equals 7y minus 3. Add 3 to both sides, and we have 7y equals x plus 3. So dividing by 7, we're going to get y is equal to 1/7 x plus 3/7. Is that what this is over here? No, it is not. So that is not correct. I do want to show in a graphing calculator what these will look like, because I don't know if people did that enough. So the first one we have is, I'm going to do part A, 1/2 x minus 11. So 1/2 x, we'll do this here, 1/2 x minus 11. And then we're going to be looking at this function here. And we're going to reflect about the line y equals x that I put here. And so there should be a function that goes up here someplace above, but we'll look at that. I guess it'll be up here where I'm drawing with the arrow. So for this one we have 2x plus 22. So let's go look at that. Two x plus 22. See what that looks like? Yeah, that's what it looks like. And we're reflecting about the line y equals x. And if we go to zoom square, we might be able to see that even a little better. Yeah, you might be able to see it a little better here. But these are inverses of each other about the line y equals x. Okay, that's 7, 8, the back page. Identify the intervals where the graph is increasing. Well, the graph is increasing here from x equals -3 all the way up to x equals 1. And again from 2 to toward infinity. So I guess we're going to 5 on here. So are we increasing for x is less than -3? No, we are actually decreasing. So that would be a no, because we're talking about this interval over here. Decreasing, not increasing. Between -3 and 1, well, here's -3 to 1. Are we increasing over all this interval? Yes, we are. What about -3 to 2? Well, for -3 to 2, we're going down this last piece from 1 to 2. So over that whole interval, we are not increasing. Therefore, the answer is no. And for x is greater than 2, are we increasing all this interval for x is greater than 2? Yes, we are. On which interval is the graph negative? Well, I'm going to clear this off, take a better look at it. The graph is negative where the graph is below the x-axis. So I'm just kind of boxing in where that graph is below the x-axis. So we are below the x-axis from greater than -5 to -1, which is answer choice B. Okay, next problem, 10. given f of x equals x squared and g of x equals quantity x minus 1 squared minus 3, choose true or false statement for each. And it has to do with, you can use your calculator, but better yet, if you understand the basic transformational properties of functions. So A, g of x is f of x translated down 3 units. Is that down 3 units? Yes. And right 1 unit. It says minus 1 here, but is that right or left? It's right. And you can easily put this in the calculator. In fact, I'm going to do that right now. We go here and we put in clear, clear, clear. We put in x squared, graph. There we have it, x squared. And I'm going to go and get the second format and put this on the line so we can see that a little better. Okay, there we go. And then the second one here is going to be quantity. X minus 1 squared minus 3. If you have a calculator in hand, especially, you should never get this wrong. So can you see that we are translated down 3 units and move to the right 1? Now, let's answer things about that, because still people made mistakes. G of x is f of x translated left 3 units and down 1 unit. That's not correct. But A can't be right and B be right also. G of x is the same shape as f of x. Well, it is the same shape, because all you're doing is you're taking this parabola right here, this f of x, and you're taking it and you're moving it 1 to the right and down 3. So it is by definition the same shape. Now, is this thing going to be any wider? So the same shape, yes. G of x is wider than that? No, it's the same shape. So what we have is, yes, same shape. Is it any wider? No, it's not. Now here's where some people might have made a mistake, because from this viewpoint, it kind of looks like the red one is wider than the blue one, but it's not. It's the same parabola, just translated, and it happens to look wider because it opens wider at the top, just because we've had 3 more vertical spaces to get wider, but it's the same width. So these are the correct answers for 10. The figure below shows a transformation of y equals absolute value of x. Refer to the figure for 11 and 12. Which function is represented on the graph? And there is really not a very good excuse for this, because at least on number 11, because you should be able to put this in the calculator and see that absolute value, second catalog, absolute value of x, okay, plus 2 is the only one that's going to match this thing right here. So C is your correct answer for this one. And you can try all these other ones. Write the range and set notation. And you can write the range and set notation in a couple of different ways. You can write this as y such that y is greater than or equal to 2. Or alternatively, you can write this as y such that y is greater than or equal to 2 and less than infinity. Either one of these would be sufficient. And I had some students who did set inequality and interval notation just to make sure they wouldn't get it wrong. Next, 13, complete the table. Here we have an x and a y. And so here in this first example, we are plugging in -2 for x. So what if we plug in 0 for x? It would look like this: 0 plus 1, absolute value point 0 plus 1 equals y. And then for this next one here, we have 2 times quantity 2 plus 1 equals y. And the last thing is just calculating what these are at the right. Well, here, the absolute value of -2 plus 1, that's -1, and -1 becomes positive. 1 times 2 is 2. In this one here below, we have 0 plus 1 inside absolute value brackets, which becomes 1. Absolute value of 1 is 1. 2 times 1 is also 2. This last one here, we have in absolute value brackets 2 plus 1, which is 3. Absolute value of 3 is 3. 2 times 3 is 6. So this is what number 13 should look like. Now, last one, 14, graph the solutions to absolute value of x minus 2 equals 1. Well, what you can do is you can definitely graph this in a calculator. I'm going to do this without a calculator. So if I go ahead and just put in this, and then come like this, make a little view. So we have that, right? But we're going to, it says -2. So what we're going to do is take this and bring it down 2 units here. Okay, equals 1. And so we're going to say equals 1, and so we draw 1. Now, if you did nothing more than do what I'm doing here and mark your points like this, I would have given you full credit for graphing alone, because you graph the solutions. But better yet, you should have put something like the point at -3, 1 here, and then 3, 1 here, and then summarize your solutions. X equals -3, 3, or you can put x equals -3, x equals 3. That'd be another way to write it. So that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.